Hi everyone, and welcome to this chapter of the free full stack course. In this chapter, we're going to focus on some of the basics of PostgreSQL. Now, we need to know that when we get started with the backend development using Django, Django abstracts away quite a lot of database management for us. That means really that you don't have to work directly actually with Postgres or any other database for that matter. Even if you were using SQLite, for instance, or MySQL, when you're with Django, when you're using Django, as you'll soon see, when we get started with Django actually in the later chapters, you don't go ahead and write, for instance, direct SQL queries, whether it's Postgres or SQLite or whatever. So it is important to understand that we don't need to go ahead and learn everything about Postgres, for instance, but we should actually learn just a little bit so that we understand at least how Postgres works under the hood, and also to get an understanding of how it relates to SQL, the standard SQL as well. There are some commands that are specific to Postgres that you can't take, and they're basically not portable commands that you can take to MySQL, but Postgres also is a SQL database. So it allows you to add SQL commands in the Postgres shell, for instance, to interact with it. So just keep it in mind. We're not going to go in very much detail about Postgres, but just some of the basics in this chapter, so at least we get a good understanding of how Postgres works. Okay, so let me do some screen reshuffling here before we get started with getting connection information in Postgres. So I'm going to go ahead and make the screen a little bit bigger in here and shift to a terminal window. If you follow the chapters chronologically, or at least you follow the chapter from the previous chapters for installing Postgres, you should now have a user on your computer called full stack course. And even if you don't create that the local user on your computer, actually the local user was only really for Unix-based operating systems, so Mac OS and also Linux. But if you're on Windows, you don't have a special user really on your computer for full stack course. But what we at least have is a full stack course role in Postgres, or a user called full stack course in Postgres. And also we should have a database called full stack course if you follow the chapters from before this current chapter, basically. So let's go ahead and go into psql at this prompt. And then I'm going to say I'm going to use the user Postgres. Actually, I'm going to use the user full stack course in here. Okay, so now we're at the full stack course database. So in order to get the connection information, you can type \c. As you can see, it says connected to which database and as which user. You can also say con info, which gives you some more information, such as the port on which you are connected. So you can see in here, con info gives you some more information than \c. So that's also quite useful sometimes, because later when we start with Django, you also need to know which port you're connected to, and that is something that you will also need to configure. The default port for Postgres, as you can see in here, is 5432. So unless you've configured Postgres at a different port upon the installation, then you don't have to worry about that. It's usually 5432. But when we later in this course go and deploy, for instance, our Django application to a service such as Google's cloud system, then the ports might be different, and that's something that we always have to take into consideration. So in order to see the port, you can also issue the command con info, not to get only the connection information, but also to see the port. Okay. So the other useful command in PostgreSQL that you can issue, as you can see, is the \du. And I can see I've increased the size of the font so much that it's almost impossible to read this information. So let me just change the size in here, and let me see if I can issue the same command again in here, \du. And if I decrease the size just a little bit more, I think then we can see the information a little bit better, as you can see in here. So by issuing the \du command, you can see all the users or all the roles, as Postgres calls them. So they're not really called users, although when you log into Postgres, you're actually using the dash uppercase U as in user to choose that role. But inside Postgres, when you're inside Postgres, these users are called roles, basically, okay? So here you can see with the \du command, a list of all the roles available in the system and also what attributes they have, meaning what permissions that they have. Here's a super user. And this user can also create roles and also can create databases. And also there are other users such as the Postgres default user that has more access to the entire system than the role that we've created. But when you create new roles, you can also assign new attributes to them or assign attributes to them. And also you can manipulate those attributes later. This is something that we're not going to play with though right now. It's not necessary for this chapter or this course at the moment, but just keep that in mind that there are roles and then there are attributes, which is their permissions, okay? Now, if you want to see also the history of all the commands that you've issued in Postgres terminal, so such as, for instance, you've issued a command and you just don't remember what it was, you can issue the \s command in here. You can see that, again, I can see a list of commands that I've issued from before, okay? So that's also quite a handy command if you've forgotten a command that you've issued before and just want to go back to it. It's pretty nice. Now, when you're in the PostgreSQL's shell in here, you may be interested in finding all the available databases, because this is a database management system as well, Postgres. So the core of it is really data and databases and tables and views and functions, of course. So if you want to see the list of available databases, then you can issue the \l command or list. So let me increase the size in here a little bit. So let's just say \l in here. Actually, the size again is too big. So let's see \l in here. Boom. And you can see in here, I can see a list of available databases. So here's a full stack course database. It's a Postgres, and then there's some templates, and also there's my other users database. So it's pretty nice command. It's very useful, \l, to get the list of available databases in the system, okay? Now, if you want to switch between various databases, like if you issued the \c to see your connection information, right now we're connected to the full stack course database. But if you want to switch to another database, you can basically use the \c command, but you specify the database you want to connect to. So let's get a list of all the databases in here, and let's just say that I want to connect to the Postgres database in here. So I say \c Postgres. Okay, and it says that I am the full stack course user, and now I'm connected to the Postgres database. And I can go back to my full stack course database like this with the \c command again, and then I can say \c to get the connection information, and also \l to get the available databases in the system. Okay. Now, there's lots of these / commands in Postgres, and then if you want to get a list of them and some help about what they actually do, you can issue the \? Command in here. And it will tell you the basics of some of these commands and what you can do with them. We're not going to go through all of these because Postgres has a lot of Postgres-specific commands. I'm just going to provide you with some of the most important commands in this chapter, so you at least know how to test the waters, okay? Now, if you want to quit this shell for Postgres, you can either type, let me actually bring the label in here. So if you want to quit your shell, you can either type quit in here, or you do the Postgres way by doing \q, and that quits the Postgres shell for you. So if you go back, you can say \q, and then you can always go back with psql. And you can also type quit. I've seen quit also work. So, but I prefer \q because it's one of the / commands, which is a Postgres command, basically, okay? So let's connect to Postgres again, all right? Now, if you're curious about the version of Postgres that you're running at the moment, you can use a select command in here. And select is a SQL command, and version is a function in here. So you say select version, and then you can see your Postgres version if you're curious about that. This is kind of important because sometimes when you're asking for help online, you may need to provide this information to whoever's trying to help you. So that person says, okay, which version of Postgres are you using? And then you can use this command that you saw in here, select version, which is a function, okay? So that's also a good command to remember. Now, if you've issued a command and then you want to issue the same command again, there are two ways of doing that. One is just to press the up arrow on your keyboard to go to that previous command, or you can just say \G. So if I say in here select version, for instance, this is the command that I issued previously. If I want to go back to it, I can either press the up arrow, which goes back to it, or I can say \G, which basically issues that command again. You can see it issued that command. All right. So \G is also useful if you want to reissue a command that you just issued. And it's kind of useful for me, at least it's useful when I'm trying to insert some data into a table. For instance, if I've done an insert into a table for a row and I want to insert it again and again and again, I can just say \G, which reinserts the same data again into the table. Okay. Okay, now that we've come to this point, also we learn about some of the basics of the / commands and getting lists of databases, for instance. You may also be curious about actually working with tables. So the databases and tables are kind of like the basics of SQL, you could say, and then you get into views and functions and etc. But there are many things you can do with databases as well, for instance, in Postgres, such as creating databases. And the command for creating a database in Postgres, you can see, is very similar to basically any other SQL database. So you'll use the create database, and then you specify an owner optionally. So if I go in here and say create database testing, then I've created a database in here. And then I can, if I issue the same command again, I'll get an error saying that this database already exists. But I can say create database testing 2, and I can say with owner full stack course. Okay, so this basically sets me as the owner of that database. Now, owners at the moment are not so useful information to really know, because we're not going to go into so much about the permissions and attributes of users, but just know that if you want to specify a particular owner for a database, you can always say create database, name of the database, and then with owner, the name of the role of that user. Okay, that's really good. Okay, so let's get a list of all the databases in here. You can see we have full stack course, and we also have testing and testing too, but we're going to be able to drop those databases using the drop database command. So if you want to remove a database, you can always say drop database. So let's say drop database testing, okay, and that dropped that database. And then if I issue the same thing again, you can see that I get an error saying that that doesn't exist. I can also say drop the database. Actually, let's get a list of all the databases again. A little bit smaller size perhaps in here. Let me quit this one. Let's get the list again. So I can see that testing 2 still exists here. So let's go ahead in here and say that I want to drop that one as well. So let's go to drop database testing 2. Testing 2. And that is dropped now. And also, if I say drop database testing 2 again, you see that I'll get an error. But there is a command which, as you can see at the bottom of the screen, is a drop database if exists testing 2. And what that does is it tries to drop that database only if it exists, and it gives you a warning if it doesn't exist. However, if you say drop database and a database that doesn't exist, then you get an error, as you can see in here. So if you just want to get a warning, meaning that your command will be successful technically, but it just won't do anything, then you can say if exists. As you can see here, you just get a notice saying that it doesn't exist. Okay, so that's also a really good command to know about. So if you want to rename a database, you can always use the alter database, and then you say which database, and then you rename it to an alter database. Is, I said alter, but I say alter now. I think it's alter. If you're altering a database, there are so many things you can actually alter with that database. And as you can see at the bottom of the screen, rename to is just one of the things that you can change or alter inside a database. Okay, so let's go ahead and create a database again. And we say testing. And then in here, we say alter database testing. Let's say rename to testing 2. Okay, and if I get a list of all the databases now, you can see now the database is called testing 2. Okay, and then we can rename it back to testing. If we say testing 2 has to be renamed to testing, and get a list of all the databases with \L, you can see now we have testing back in here. Okay, So that was about altering the name of a database. So if you want to also change the owner of a database, you can use alter database again, but in this case, instead of saying rename to, you're saying owner to. So let's say in here, if I get a list of all the databases in here, you can see testing is owned by Full Stack Course at the moment, which is my user. But if I want to change it to be owned by Postgres user in here, for instance, because if you issue the du command, you can see we have a user called Postgres. So I can say alter database testing, and then we say owner to Postgres, okay? And if I get the list of databases again, we can see testing is now owned by Postgres and not by Full Stack Course anymore. Okay, so that's also a good command to remember. Let's drop that table now. So we say drop table, and I think it was called testing. Doesn't exist. Okay, let's get a list of all the it does exist, but it's actually owned by Postgres. So let's see if we can alter it back. So we say alter table testing owner to Full Stack Course. Okay. Testing. Oh, it is not owned really by us at the moment anymore. Actually, we're not altering tables. We're altering databases. Sorry about that. So we say alter database testing owner to Full Stack Course. That's really good. Okay, and then we get a list of all the databases, not tables. And then let me just drop this database. So drop database testing, not tables. Okay, it should have worked even without changing the owner. So my mistake was that I was dropping a table instead of a database. So that's very important. So if you want to drop a database, just say drop database. Okay. Okay, that's really good. Let's go ahead now and talk about creating tables. So creating tables is an operation that Django is going to take care of for you. So you will never really have to go ever into Postgres and directly say that you want to create a table. But still, if you're trying to learn SQL, it's important to know about creating tables and databases manually as well. So the syntax for that is create table, and you can optionally say if not exists, the name of the table, and then you specify your columns basically. So let's go ahead in here and we say create table if not exists, and we name it foobar. Okay, and then we say ID is serial primary key in here. Okay, and let's just go ahead and create it and end your commands, always SQL commands, with a semicolon. Okay, so in here we got create table if not exists foobar, and then you can say \du. These are for our databases also. Let's go in here and see which database we have in here. Full Stack Course. Good. Okay, so now that we've created this table, let's go ahead in here, which is called foobar. We may actually want to see the list of all the tables in the system or in the current database, because if you get our current connection information, we're connected to the Full Stack Course database. And if you want to see all the available tables in this database at the moment, you can issue the DT command, as you can see in here. So we have name, car, foobar, and owner. I've already created a car and owner from before. So let me just drop them. I say drop table car and drop table owner. So if we say \DT, we just have foobar at the moment. So let's just go ahead with that. Okay. Now, if you're curious about the schema of a table, so how that table is created, like what the relationships are, if it has a primary key or foreign key, what columns it has, what constraints those columns have, you can always issue the \D and the name of your table command. So \D foobar, and there's no semicolon required for PSQL command. So \D, name of the table, and in here you can see the schema for your table. So this is which column. It has an ID column. Its type is an integer. It is not nullable, meaning it has to have a value because it was a serial primary key. And you can see in here, it says the default value is actually a function in here, because when you have a serial primary key, then it uses a specific function in PSQL to insert new values in that column for you whenever you create a new row. Okay. So as you can see, also here is a primary key constraint on that. All right. Now, if you want to drop a table, so you can just use the drop table command in here. So you say drop table foobar, okay? And if you issue the same command again, you get an error, but you can always say drop table if exists. and then you only get a notice saying that it doesn't exist. Okay, so let's just go ahead and create that table again after we've dropped it here. Okay, so we have foobar, great. Now, let's talk about also auto-generated identity columns. So this is a perfect way of creating primary keys. So let me actually go ahead and drop that table again because I don't think we need it. Foobar, okay? So if you want to go ahead and create, for instance, a table, soon we'll do that actually right after this with a primary key. The base for primary keys in Postgres is actually using an int field, which is an identity, and it's always generated for you. So it's not a default identity. What that always command does at the bottom of the screen, you can change always to default, but we're not going to do that. But what happens is that if you go ahead and use always, then you can't change the value of that field, because if you change it, it will always generate a new one for you. But if you say default, then when you create a new row in that table, then it generates a new ID for you. But if you go ahead and change that manually, that ID, then you're able to do that with default. But in my opinion, at least, it's always better to go ahead with always, because you know that that field is always managed by PSQL itself. So let's go ahead and create a table. So we say create table, and we call it owner, for instance. Let's say an owner of a car. And then in here, we go ahead and create a field for it. So we say it has an identity, okay? It's an integer. And we say it's a generated always as identity, okay? Great stuff. And then we just issue this command. And then you can see we have a create table in here. So, okay. If you want to get the schema for this table, remember you can always issue the \d command in here. So we say owner, and you can see it is a generated always as identity field. Okay. However, this is not primary key yet. Okay, so if you want to make this key primary key, you actually have to add a primary key constraint to this table creation. So let's drop that table. Then we say drop table owner, okay, and we want to now create a primary key for that table. So let's go ahead in here and say create table owner, and then you can see that we have an ID field, but at the end of the creation of the columns, in SQL, you can specify your constraints, and the primary key constraint is just written as primary key, and then parentheses and the name of the field that has to be made into a primary key. Okay, so let's just enter this, and then we do a \d to get the schema for this table. I'm going to say owner. Okay, and now you see that it is generated always as identity, and also it is a primary key in here. Okay, so that's very important if you want to create primary keys. Now that we have primary keys, how do we go about creating foreign keys? Now, foreign keys are also constraints, and you create them, as you can see at the bottom of the screen, with a constraint called foreign key on that column. And then you say it references which primary key. So let's go ahead and create a table in here. We say create table car, because we have owner, and then we're going to go ahead and create car. Okay, so let's say car itself has an ID, which is an integer, and then we say is generated always as identity. So this is a primary key of the car table. And then we say that it has a, for instance, let's say, an owner ID, okay, owner ID in here. And we say owner ID is an integer, but we haven't really basically entered any data for this owner ID. So the idea here is that the car is going to be a table, and it has a foreign key into the owner table's primary key. So if we have an owner with the ID of 1, and then we have a car with an ID of 1, for instance, or the ID of 20, this car can have an owner ID of 1, meaning that it is linked to that owner with that ID. Okay, so the goal for this owner ID is to have it as a foreign key into the owner table soon, as you'll soon see. Okay, so first we create the column for it, which is called owner ID as type integer. And then we're going to go ahead and first of all make this ID field for the car table a primary key. So let's say primary key ID. Okay, and then we're going to go ahead and make this owner ID field as a foreign key. So the command for that is you say foreign key. So we say constraint, okay, in here, and we say the constraint is foreign key owner, for instance. So this is the name of it, for instance, for us. And we say it is a foreign key into the column of owner ID. and we say it references owner on its ID field, like that, and a semicolon. Remember, you always have to end your SQL commands with a semicolon. Otherwise, you'll be scratching your head here in the shell, thinking, why is it not creating the table for me? So now we have the car table, and we have the owner table. So then what you can do in here, you can issue the DT command to get a list of all your tables. So we have a car and owner, and let's get the schema for car. Okay, so you can here see that we have an ID and an owner ID. And owner ID is actually is a foreign key referencing the ID field or ID column of the owner table. Okay, so that was really it for primary keys and foreign keys. There's more to talk about, but I think we're not going to go ahead in too much details about primary keys and foreign keys, because again, that's something that Django will really manage for you really well. However, sometimes when it comes to migrations in Django, you may not know about migrations yet, but if you're changing your database model in Django quite a lot and doing very complex operations, then Django may not actually be able to do the migration for you. So it will ask you about things. It will like, oh, did you just change this field to that, or did you change this primary key to that, or did you change this foreign key to another field? If it asks you those questions, then it's always beneficial for you to know some of these basic information about SQL and how primary keys and foreign keys work. So if you're curious about this type of stuff, I highly suggest that you go into PSQL yourself and also play with primary keys, foreign keys, tables, and databases. Okay. Now that we have tables, how do we go ahead and add data to them? The format for adding data into a table in SQL basically is using the insert into. So let's go ahead at the moment and get the schema for our table. So here are our tables, and we are going to get the schema for instance, car. You can see we have ID and owner ID, but we have no name really on this car table. So let's drop the table of car, okay? And then we're going to go ahead and create it again. So in here we have the ID and owner ID, and let's go ahead and actually create a name as well for this car. So we're going to say name is a variable characters of 255 in here, and then we make it, and then we just enter this command. Okay, so now we have create table. So we have owner, and if you get the schema for owner with \d, you can see that it has, oops, not owner, sorry, car. Car has a name as well. Okay, so let's go ahead and actually insert something into these tables. So in order to insert something into car, we actually have to have an owner. So let's say if we go to drop the owner as well. So drop table owner, okay? Because we can't drop that. Let's just say drop table owner cascade. I mean, I'm not going to go so much into details about that. What I want to do right now is to go ahead and add a name column to the owner table. And at the moment, I could use alter table, but we haven't gone into details about that. So the easiest thing is to drop that table and then recreate it with a name field. However, I can't drop it at the moment, as you can see, because the car table has a foreign key relation to the ID of the owner table. So if the car table had some data, for instance, it has a car that is connected to the first owner in the owner table, then what happens if I drop the owner table? Then the relationship between that car and the owner table is going to be kind of broken, because it's connected to an owner whose table is entirely dropped. So what is happening here is that PC or SQL in this case is telling us that, hey, wait a minute in here. If there are any relations between the car and the owner table, how do you want me to handle it? And by providing cascading here, what I'm saying is that if I'm deleting and dropping the entire owner table, also delete any objects that are related to it, meaning that if there is a car whose owner is, for instance, one of the owners in this table, delete that object also from the car table. So let's issue this command. Okay, notice drop cascades to constraint. That's fine. Okay, so let's let's do DT in here. So we only have the car table in here. Okay, so let's go ahead and create the owner table again in here. Okay, we have ID, and let's go ahead and add a name in here as a varchar 255. Okay, great stuff. So we have owner and DT, great stuff. So if we want to go ahead and add an owner to this table, how do we do that? So we say insert into owner, and then you specify the name of the columns. So the name of the column that we want to actually insert data into is called name. Okay, and then you specify your values. So let's say the first owner is owner number 1. Okay, and a semicolon. Okay, so here I shouldn't specify a single quotes. I should just specify the name of the columns and semicolon in here. Boom. All right, so that was the owner. Okay, and that's how you insert basically values into a table. After inserting values into a table, you of course want to go ahead and read those values. So let's insert another one, owner number 2. And then you can say select all from owner. Okay, and you can see owner number 1 and owner number 2, and you can see the ID field is actually being auto incremented for us, so we didn't have to insert any IDs into the table of owner. Okay, so if there's any fields that you have in your table and you want to make sure that those fields are never left empty, then you can use the not null value, basically, the not null constraint, telling the column not to ever have the value of null, meaning that it has to always have a value. Okay. Now, we are now going to go ahead and create our test tables. As you can see, I've said that we need to create the owner and the car tables with name fields of varchar 255 and foreign key and ID. But we've already done that. So we've already created these tables. So if you haven't done the owner and the car tables, here's how you create the owner table. All right. And this is how you would create the car table. Okay, so you can pause the video at those points and then go ahead and create these test tables because they're kind of important for the rest of this chapter. So let's go ahead and insert some test values into our tables. So if you say select all from owner, we have 2 owners, but if you say select all from car, we don't have any cars. So if we get the schema for the car table, we can see that we have ID, owner ID, and also name. So let's go ahead and create, for instance, a Tesla car and with the owner ID of 1. All right, so let's say insert into owner, into the fields of owner ID and also name, and then the values are 1 and the name is Tesla Model X, for instance, in here. Okay, and then a semicolon. And here it's saying column owner ID of relation owner does not exist. Insert into owner ID, name values 1. Okay, let's get the schema for our car again. So car, we can see owner ID is here. And it's generated as always. Okay, owner ID integer. I think the owner ID is kind of like the foreign key has kind of disappeared. So let me just drop this table, drop table car, and let's go ahead and create it again in here. Let's see here, like that, semicolon. All right, so let's insert into that now. Oh, we're getting a relation does not exist. And I can see actually now what the problem is because we're inserting into owner, but we should be inserting into car. So let me go ahead in here and say insert into car. And now we can see that we've inserted a Tesla Model X with the owner ID of 1 into the car table. But if I go ahead and insert, for instance, owner with an ID of 1000 in here, you can see we're getting an error from SQL telling us that an owner on the owner table with that ID, which you're inserting into the car table, does not exist. So the foreign key is working quite fine. All right. Now, how do you go ahead and delete data from a table? So if we go ahead in here, let's go into our owners table. So we say select all from owner, okay? And we can see we have owner 1, 2. Let's go ahead and insert some more owners. So let's go ahead in here. owner number 2, and let's go ahead and insert owner number 3. And also, if I want to insert owner number 3 again, I can just say \g, and you can see that same command was issued again. So that's where \g is quite useful. Okay, and let's grab all the owners now. We can see that we have 1, 2, 3, 3. Okay, and if you want to delete all the rows in this table whose name is owner number 3, then you can issue the delete command. You can see delete from table where some condition is met. So we say delete from owner where name is equal to owner number 3. Actually, here it should be a single quote. So we say owner number 3 and semicolon. And you can see there are 2 rows that were affected. So if we say select all from owner, we don't have owner number 3 anymore. So we can insert it again if you want to, and then \g, and then we have 2 owner number 3s again. Okay, and their IDs are different now. Good stuff. If you want to delete all the rows inside, so if you want to delete all the rows inside a table, you can just say delete from owner, but this is very rarely used. I mean, I don't really use this command, almost never, but if sometimes you're trying to clean some tables, for instance, and you're testing out things, then you may need this command. So you usually say delete from, as you can see in here, delete from where a condition is met. But if you just say delete from that table, then everything is going to be deleted. But just please be careful with this command, because you most certainly never, almost never want to issue this command, for instance, in production environment. Okay, because all your data for a specific table is going to be gone, unless that's specifically what you want to do in production. Okay. Okay, so if you want to select all rows from a table, we've already done this, but you can issue the select star from owner, for instance, and you get all the rows in that table. Okay, now if you want to select a specific column, so for instance, you just want to see the names, you can just say select name from owner. Like this. You only see the names, so you don't see the IDs. And you can also specify select here, and let me just see, select ID and name from owner. You can also specify with a colon in between the column names to get multiple columns. Okay, and actually, that's something that I think I ran ahead on myself. But if you want to select multiple columns, you then specify a little colon between the column names in here. Okay. All right, that's really good. Now, when you get then more and more into SQL, you sometimes may want to, for instance, do some operations of select operations where you're being very specific about what you want. Now in here, we have 2 owner number 3s, okay? And if you want to, for instance, grab any row from this table whose owner name starts with OW, for instance, then you can basically issue the command as shown at the bottom of the screen. You can say select everything from owner where name like, and then you say you start the string, how it basically gets started, and then you say percentage. And you can see it basically shows you the name, it shows you all the rows whose name starts with OW and then anything after that, okay? Now, you can also go ahead and change the position of this percentage mark to the beginning of this string, meaning that anything, it starts with anything, but it can end with a specific thing. So in here, let's select everything from owner again. So you may be looking for owners who end with number 3. Then you can say select from owner where name is anything, but it should always end with number 3. Okay, and you only get owners whose name ends with number 3. Okay. Now, if you want to, and as you can guess now, if the percentage sign in the beginning means that anything and then ends with something, and at the end it means starts with something and it ends with anything, then the percentage sign is kind of like a wildcard match sign, basically. So if you want to find strings that contain a specific value, so the beginning doesn't matter, the end doesn't matter, you're only interested in what it contains in the middle, then you can use this syntax percentage, and then you write something in here. Okay, you can see this is okay. Here are all the names that have NER in the middle. And you can also say like this. So it doesn't necessarily have to be in the middle, but it is anywhere in the string itself, okay? So there is a lot more to SQL, as you can see at the bottom of the screen. I mean, if I want to create a SQL course, I think it would be upwards of 20, 30 hours. There are some good SQL courses out there if you're interested in SQL as itself. I know Free Code Camp has a beta version of one of their relational database management systems courses out there. So you're more welcome to test that out if you're specifically interested in working with SQL. But when it comes to Django, as you'll soon see when we get into the development of our Django application, you don't really need to know SQL. I mean, it's kind of, I always suggest actually any software developer to learn SQL because it's such an important skill these days, specifically to learn how to work with SQL. Even if you're just doing front-end development, you're most definitely are going to get to a point where you need to know SQL. Even if you're working with Firebase, sometimes you may need to know the basics of SQL to understand how Firebase works, even though it's a document-based storage kind of, or it has that functionality. At least Firebase is a lot more than that. So what I think is that you should be aware that when you get to Django, you don't have to know SQL, but it is always a huge plus if you can work with SQL. So go ahead and look at the Free Code Camp link, please. And if you have free time, go ahead and learn more about SQL, or at least experiment with it. Okay? So I give you a huge congratulations here, because I think now you know at least the basics of Postgres and SQL in here. You know some of the basic commands of working with Postgres, seeing databases, roles. You can see tables. You can issue previous commands. And yeah, the basics. You can see the schemas of tables. And there's lots more to psql commands, which you can get basically with \?. So if you're curious, you're more welcome to just go ahead and explore this command, and maybe there are some more commands that are interesting, which you think the community needs to know. In that case, please go ahead and leave them in a comment section at the bottom of this video. Or if you have any questions also, please let me know. And don't forget to join our Discord group. The link to the Discord group, you can find it in the playlist for the free full stack course. The link to the free full stack courses playlist is the first link in the description of this video. Go ahead and open that, please. And then the Discord invitation is also in there. So I hope you enjoyed this chapter, and I'll see you in the next one.